In this video, we are going to go over the Side-Side-Side Inequality Theorem. This is sometimes known as the converse to the Hinge Theorem. T39 for us says that if two sides of a triangle are congruent to two sides of another triangle, and the third side in that first triangle is longer than the third side of the other, then the angle between the congruent sides in the first, so that included angle, otherwise known as the angle opposite the longer side, is greater than the corresponding angle in the second triangle. Let's look at a picture of this. Again, we're going to have triangles ABC and triangles XYZ. We're going to say that AB is congruent to XY and AC is congruent to XZ. We're also going to say that this side BC is greater than the side YZ. Well, we need to prove then that angle A is greater than angle X. In the last theorem, SSS Inequality Theorem, we knew that the one angle was already greater than the other angle. But here, we have to prove that one angle is greater than the other angle, knowing that one side is greater than the other side. And for this theorem, we're going to use proof by contradiction. What we're trying to prove is that the measure of angle A is greater than the measure of angle X. So let's assume that this conclusion is false. So writing down what we're given, and then I'm going to say, assume that the measure of angle A is not greater than the measure of angle X. If it's not greater than, it's saying that the measure of angle A is less than or equal to the measure of angle X. So, the measure of angle A equals the measure of angle X, or the measure of angle A is less than the measure of X. So we're going to have two separate cases. Case 1, we have that the measure of angle A equals the measure of angle X. Think about it. If angle A is congruent to angle X, then we can use side angle side to say that triangle ABC is congruent to triangle XYZ. And if the triangles are congruent, the corresponding parts are congruent. So BC is congruent to YZ. So BC is equal to YZ by the definition of congruent segments. But this contradicts the fact that we're given that BC is greater than YZ. So we've reached our contradiction for case 1. Let's move on to case 2. Case 2, we have that the measure of angle A is less than the measure of angle X. But think about the theorem we went over in the last video, SSS Inequality, or the Hinge Theorem. We're saying that this angle X is greater than this angle A. So by that Hinge theorem, we have two sides are congruent to two sides of another triangle, and the included angle of the first triangle is greater than the included angle of the second triangle. So YZ is greater than BC. Or in other words, BC is less than YZ. But BC being less than YZ directly contradicts what was given to us, that BC was greater than YZ. We've not only contradicted case 1, but we've reached a contradiction with case 2. Therefore, since both cases lead to a contradiction, our original conclusion must be true, that the measure of angle A is greater than the measure of angle X. QED. We have proven what we wanted to prove. The side-side-side inequality theorem. If two sides of a triangle are congruent to two sides of another triangle, and the third side of the first triangle is greater than the third side of the second triangle, then the angle between the congruent sides in the first triangle is greater than the angle between the congruent sides in the second triangle.